Hello everybody, welcome into another lesson. So today is going to be the first of 3 trigonometry lessons. Well, at the beginning of this course we talked about geometry, which geometry comes from Greek words that mean earth measurement. Well, trigonometry comes from Greek words that mean triangle measurement. In this course, we're going to do very rudimentary basic trigonometry that only pertain to right triangles. Now, when we get into Algebra 2 trig, and then into pre-calc after that, we'll discover other applications of trigonometry. But in this course, it's going to be fairly easy. So today we are only going to talk about the tangent ratio. The next lesson we'll talk about sine and cosine. So here you have a right triangle. Again, the trigonometry we're doing only pertains to right triangles. If you wanted to find the tangent of an angle, in this case you have the tangent of angle A here, that's always equal to the opposite leg over the adjacent leg. It's the ratio of the opposite leg over the adjacent leg here. You never, for tangents, you don't factor in the hypotenuse. Now, when we get to sine and cosine, you will, but for tangents, it's only the opposite leg over the adjacent leg. So you also see it abbreviated as tan A, or whatever angle you're trying to find, equal to opposite over adjacent. And that's how we're going to do our problems today, the tan of whatever, but that means tangent. And how can you remember that a tangent is opposite over adjacent? Remember this acronym, TOA. If you can remember TOA, it stands for tangent, opposite over adjacent. If you can remember TOA, you're in good shape. Now, when we learn sine and cosine in the next lesson, there's another part to that acronym, but we're only doing tangent today. So we're going to hold off on the other 2 functions. There's actually 3 more functions than what you're going to learn in this course. There's cotangent, which is the reciprocal of tangent. It would be adjacent over opposite. Then you have secant and cosecant, which are reciprocals, functions of sine and cosine, but we're not going to cover those in this course. But let's get started with our first problem here. Okay. So I'm going to draw a right triangle. Alright, so what do we have here? It should be, 58. Let's see what we got here. Length of this leg is 22. The length of this leg is x. So we're going to use the tangent ratio to solve for x. Now, yesterday we talked about 45, 45, 90 right triangles and 30, 60, 90 right triangles. Trigonometry is particularly useful if it's any other type of triangle besides those 2 and you only know the length of one side. It'll enable you to find the length of other sides. But today we're only doing the tangent, so we need to find x. There's a couple ways you can do this. You can either find the tangent of 32 degrees. So tangent of 32 degrees is how you'd write that, is equal to the opposite side, which is x, over the adjacent side, which is 22. That's the tangent of 32, or you can always do the tangent of 58, which would be equal to the opposite side of 22 over the side adjacent to the 58, which would be x. Personally, I'm going to go with this one here because if you go with this one, you're going to have to multiply both sides by x, and then you're going to have to divide 22 by the tangent of 58, which actually is a little bit more work. So if you can, try not to make as much work on yourself. Alright, so of course we want to solve for x. You need to multiply both sides by 22. You would end up getting x is equal to 22 times the tangent of 32 degrees. Now we're going to round our results to about 2 decimal places. We're going to get an approximation here. Oftentimes with trigonometry, kind of like pi or some other non-repeating decimals, most trigonometry answers for degrees are very much repeating non-terminating decimals. So that's why you'll often get a decimal approximation. Now in your calculators you should see a tangent button, but there's one disclaimer I want to go over real quick. It is very important that your calculator is set to degrees, because if it's set in radians, you're going to get a completely different answer. We're not going to do radians in this course. We will in Algebra 2 Trig and in Pre-Calc, but you want to make sure you do degrees. So now we just take 22 times the tangent of 32 degrees, which would give us a length of about 13.74. So x is approximately equal to 13.74. On your calculator, if you see a button that says rad, that means you're already in degrees. If you see a button that says deg, D-E-G, that means you're in radians and you need to hit that deg button in order to switch to degrees. So that's very important for doing these. So when we do this, x is approximately equal to 13.74. Alright. I think we'll keep this triangle, but we're going to change some lengths. And some angles, of course. Alright, what do we have next here? This is 27 degrees. This is 63 degrees. This has a length of x. This has a length of 12. So, we need to solve for x. I would always personally recommend, if you can, if you're able to, set up your tangent ratio in such a way that the x, or the undefined value, is always going to be in the numerator. Since tangent is opposite over adjacent, we probably want to go with the tangent of 63 degrees. So we can set this up as the tangent of 63 degrees is equal to the opposite side, which is x, over the adjacent side, which is 12. So now we've set up our ratio. Well, let's solve for x to start with. Multiply both sides by 12. You get x is equal to 12 times the tangent of 63 degrees. And then again, you're going to get another decimal approximation. Just make sure your calculator's set to degree mode so you get accurate results. So now let's do this. So 12 times the tangent of 63 would give me about 23.55. So x is approximately equal to 23.55 when you do the math here. So the tangent ratio really isn't that bad, to be honest. It's really not. I know people see trigonometry at first and they freak out. It's like, oh my gosh, this is trigonometry. Trigonometry is really not bad at all, I promise you. Alright, a little bit different triangle, but by now we should be used to seeing funny tilted right triangles. Alright, this angle is 44 degrees. This, let's see, what is that side? Yep, this is x. This is 50. So we're going to solve for x, of course. Alright, so ultimately we want to use the tangent ratio to solve for x. So we know the 44 degree angle. Go ahead, set up your tangent of 44 degrees. That's going to be equal to the opposite leg of x over the adjacent leg with length 50. Now, of course, then you multiply both sides by 50, you would get x is equal to 50 times the tangent of 44 degrees. And then we should get another decimal approximation. So let's go ahead and input this bad boy. You get that x is about 48.28. So x is approximately equal to 48.28. That's what you would get. All right. Let's see here. Here's the right angle for this triangle. X 1.2. This is a 50-degree angle here. Okay. So once again, we want to find the value of x using only the tangent ratio. Well, so we'll go ahead, we know the 50-degree angle, set up the tangent of 50 degrees. That's going to be equal to the opposite leg, which would be x, divided by your adjacent leg, which would be 1.2. So tangent of 50 degrees equals x divided by 1.2. Now just multiply both sides by 1.2. Well, actually I want to put x on the other side. So x would equal to 1.2 times the tangent of 50 degrees. Then we'll get a nice decimal approximation for this. It comes out to about 1.43. So x is approximately equal to 1.43 when you do the tangent function in the calculator. All right, next. Here's another right triangle. X 100 and 61 degrees. Okay. So we're still, of course, finding the value of x. So we're going to go ahead and set up our tangent of 61. We'll set up the tangent of 61 degrees, which would be equal to the opposite leg of 100 over the adjacent leg of x. Which this is going to be fun, because you multiply both sides by x, you would end up getting x tangent of 61 degrees equals 100, which then to solve for x, you would just divide both sides by the tangent of 61. So x is equal to 100 divided by the tangent of 61 degrees. And then we should get a nice decimal approximation. So yes, sometimes you'll have it switched around where the variable's in the denominator, then you just got an extra step or two. which is about equal to 55.43. So x has a value of approximately 55.43. All right. Another one here. See what else we got here. X 7.1. This is 25 degrees here. Okay. So again, we're going to solve for x, and then we're going to set up our tangent ratio then. So we'll take the tangent of that 25 degrees equal to the length of the opposite leg, which is x, over the length of the adjacent leg, which is 7.1. Which has to mean then that x would equal 7.1 times the tangent of 25 degrees. Then we should get a nice decimal approximation for this. Which gives you about 3.31. So the length of x is approximately equal to 3.31. That's what you would end up getting. Alright, so we found missing lengths. We've used the tangent ratio to find missing lengths. Now, this is about to take another interesting spin. So, let's see what we got this time. This side is 6.1. This side is 4. This angle is y degrees. We need to solve for the missing angle this time. Of course, this is a right triangle. Let me specify. Okay. You can also use the tangent function to solve for missing degrees. So I'm going to set this up the same way. I'm going to take the tangent of y degrees, set that equal to my opposite of 6.1 over my adjacent of 4. Now, how am I going to just solve for the degrees? Well, in your calculator, you should see something called the tangent inverse. It'll look like tan to the negative 1. That's the inverse tangent function. So what you'll need to do is the tangent inverse function of the tangent of y degrees, of course, would equal the tangent inverse of 6.1 over 4, which then tangent inverse of tangent unlocks the function and just makes it y degrees. We're going to round to the nearest degree. Y degrees equals, well, it's equal to the tangent inverse of 6.1 divided by 4. But again, like in the previous exercises, make sure your calculator is set to degree mode, not in radians. So we're going to round our result to the nearest degree. The tangent inverse will give you the degree of the missing angle you're seeking. There we go. Tangent inverse of Now, I should also write a disclaimer here too. The tangent inverse, if you don't see that on your calculator, it's also often called the arctangent. I almost forgot to mention that. Both of these here mean the same thing. Both of those mean the same thing. Tangent inverse or arctangent. Those are the inverse tangent functions. But when I do it, I get an angle of approximately 57 degrees. So the value of angle y is approximately equal to 57 degrees. I'll leave that up there for a minute. Okay, what do we have here? The right angle right here. Alright, so we're still going to solve for y degrees. Well, it looks like they try to trick you because they give you the length of all three sides. They give you the length of the hypotenuse. If we remember, the tangent has nothing to do with the hypotenuse, so we can forget about the hypotenuse. Just focus on your two legs. So the tangent of angle y, tangent of y degrees, is going to be equal to your opposite leg of 8 over your adjacent leg of 15. Then you take the tangent inverse of the left side, that would just make y degrees by itself would be equal to the tangent inverse or the arctan, however your calculator has it, of 8/15. Which then means y would approximately be equal to what? And again, make sure your calculator's in degree mode. It's approximately equal to 28 degrees. So angle y has a measure of approximately 28 degrees. Good one. N 2n, n times the square root of 5. Then we have y degrees. Okay, so we have the lengths of all three sides of the right triangle, but again, the tangent ratio has nothing to do with the hypotenuse. You're only caring about the adjacent legs. So we're going to solve for y. Of course, set up your tangent of y degrees. That's going to equal your opposite leg of length n over your adjacent leg of 2n. The disclaimer whenever you have variables are, make sure you don't have a variable that equals 0 in the denominator, that both of these n's have to be any non-zero number, actually any positive non-zero number. Since this is geometry, trigonometry, it's always positive, which means the n's will cancel out, so really the tangent of y degrees would really equal 1/2. So now you just take your inverse tangent function, you'll get y degrees is equal to the tangent inverse of 1/2. And then we'll get an answer here. Let's find the tangent inverse of 1/2. which is approximately 27 degrees. So angle Y is approximately equal to 27 degrees. That's what you end up getting. All right. Here's your right angle. 4n, 3n, and then the hypotenuse has a length of 5n. And then which angle has the y? This one does. Okay. So again, we're going to solve for angle y. So go ahead and set up your tangent ratio. So the tangent of y degrees equals your opposite leg of 3n over the adjacent leg of 4n. Again, we know the n's will cancel out since they're any positive non-zero number. So the tangent of y really equals 3/4, which means y degrees is equal to the tangent inverse of 3/4. So once we run that, we should get a decimal approximation. Which would give us about 37 degrees. So angle Y is approximately equal to 37 degrees. All right, what's next? Oh, good one. This is a good one. Well, they really threw the book at us for this one here because we have a missing leg. We know the length of the hypotenuse and one of the legs. Well, the tangent ratio does not involve the hypotenuse. So I'm going to call this missing leg length x. We're going to temporarily solve for x. So we'll do our Pythagorean theorem here, of course, to solve for the missing length, which would end up being x squared plus 2 squared is equal to the square root of 13 squared, which would give you x squared plus 4 equals 13, which would then give you x squared equals 9, and we know the positive square root of 9 is 3. So the length of this side here, the length of this leg now is going to have a length of 3. Now we're in business, we can solve our tangent. So sometimes you'll have to solve for missing other pieces that weren't asked for in order to get what you're asking for. Now that we have both legs, we can set up our tangent ratio and solve for y. So if we take the tangent of y degrees, that's going to be equal to our opposite leg of 3 over our adjacent leg of 2. Which then means, of course, that y itself would be equal to the tangent inverse of 3 over 2. And then we should get a decimal approximation here for how many degrees y is. So we'll take the tangent inverse of 3 over 2, which comes out to approximately 56 degrees. So y is approximately 56 degrees. That's what you end up getting in the end. All right. I have about 6 more exercises here that really do push everything we've learned today and in the past. So let's go ahead and do these real quick. And let's bring this down a little lower. What else do they give us? This is split right down the middle here. So this forms a right triangle, which by default this would too. They even give us that these two sides are congruent to each other, so the whole triangle is an isosceles triangle. This is 42 degrees. This has length W, this has length Z. The length of this whole segment is 120. So first we need to solve for, we're supposed to solve for W then Z. But here's the thing. It's actually going to be easier if we solve for Z first. Well, no, we'll have to solve for W first. So how are we going to do that? How do we do that? So we know this here is also a 42 degree angle, which means these sides are congruent. You have a hypotenuse and a leg congruent, right? Which means these two right triangles are congruent to each other by the hypotenuse leg theorem, the HL theorem. So that means this segment here is congruent to this segment here by CP/CTC. Corresponding parts of congruent triangles are congruent. So this segment here would also be W. Now we can go right and solve for W, because the sum of W plus W equals 120, which means 2W equals 120, which then means that W equals 60. So we found the length of W to be 60. Now let's look at Z. In fact, I'm going to put this in here. Since we just found W, the length of each of these is now 60. We can readily solve for Z. If we take the tangent of 42 degrees, that's equal to the opposite leg, which is Z, over the adjacent side, which is 60. Which then means Z is equal to 60 times the tangent of 42 degrees, which then we'll get a decimal approximation to 2 decimal places. So let's go ahead and do that real quick. It's approximately equal to 54.02. So the length of Z is approximately equal to 54.02. Okay, so W has length 60, Z has a length of approximately 54.02. 5 more exercises, then we're done with the lesson. Okay. This time it sets the triangle upright. What else do we get here? Yes, we get that coming straight down, making a perpendicular line here. So that means by default, these two triangles that it's split into are also right triangles. We even get that these two sides are congruent to each other. We get that the length of this leg is 200. We get that this angle here is 35 degrees. We get that the length of this is W. We get that the length of the entire side here is Z. So, we have our two right triangles. We're going to solve for W then Z. Well, using your isosceles triangle theorem, if these two sides are congruent, that means these two angles are congruent. So this would also have to be 35 degrees. And by two reasons, we can say that these two right triangles are congruent. Of course, the hypotenuse and the leg, or you could even say hypotenuse acute angle. Either one would prove that these two right triangles are congruent. So that means that this side would also have to have a length of W. Now take your pick for which W you want to solve for. Of course, we're going to set up our tangent of 35 degrees and solve for W. That's going to be equal to the opposite leg of 200 over your adjacent leg of W, which would then give you, of course, W times the tangent of 35 degrees is equal to 200, which then W would equal 200 divided by the tangent of 35 degrees. Which then, of course, will do our division here, and we'll get a decimal approximation. Well, let's see, 200 divided by the tangent of 35. Alright, so W is about equal to 285.63. So the length of W is approximately equal to 285.63. So there we go, we found the length of W. Now we need to find the length of Z. Well, Z, of course, is simply W plus W, which means Z equals 2W, which would end up giving you Z is approximately equal to 2 times that 285.63, which would give you an approximate result for Z also. So let's see, 2 times 285.63, it's approximately 571.26. Alright, so W came out to be approximately 285.63. Z came out to be approximately 571.26. So knowing your past theorems, like the isosceles triangle theorems and proving right triangles congruent, those really do come in handy on some of these. I got 4 more exercises, then we're done. A little bit different here. Let's see where we get this time. Goes up from here to here. We have a right triangle here, which by default would make this one a right triangle too. What else do we get? This leg has length W. This is 150. This is 30 degrees. This has length z. This has 40 degrees. Okay. So once again, we're going to solve for w and z. We have one big triangle split into two right triangles. But what do we notice here? What do we notice? That we actually, the left triangle is a 30, 60, 90 triangle. So we can apply that trick. The side opposite the 30-degree angle is your shortest leg, which is w, right? We know in a 30, 60, 90 triangle that the hypotenuse is twice the length of the shortest leg. So we're going to take the length of the hypotenuse and divide that by 2, which w would give you exactly 75. So by using the 30, 60, 90 theorem, we were able to determine w equals 75. So we didn't even need to do trig for that one. But for this side we will, because now we got to try to find z. We have a 40-degree angle here. So you'll go ahead, set up the tangent of 40 degrees, set that equal to the opposite side of 75 over the adjacent side of z, which would then give you z tangent of 40 degrees equals 75, which then means that z equals 75 divided by the tangent of 40 degrees, which then we should get a decimal approximation to 2 decimal places. So let's go ahead and solve that. It comes to about 89.38. So z has a length of approximately 89.38. So this was an example of still using previous material, like your 30, 60, 90 triangle, and then the new trig stuff we learned. And if you can save yourself from doing trig, if you can just use 45, 45, 90 or 30, 60, 90, feel free. Everything we've learned so far is accumulated, so that means you can use any method from the past to solve stuff, as well as the new stuff. Alright. I just have 3 more, everybody. We're almost done. That forms 2 right triangles again. Alright, so we got 2 right triangles here. This is 45 degrees. This has a length of 82. This has a length of z. This is 28 degrees. This has a length of w. Alright, well, we have 2 right triangles again. This time the left triangle is a 45, 45, 90 triangle. And then we have a triangle to the right where we'll have to do some trigonometry. But let's solve for w first. We can use the properties of a 45, 45, 90 triangle. We know that this leg here is 82, which means this leg here has the same length. W would equal 82, since it's a 45, 45, 90 triangle. So that one was actually pretty easy. Now, we need to, of course, solve for z, which means we need to set up the tangent ratio of 28 degrees. So the tangent of 28 degrees equals the opposite leg of 82 over the adjacent leg of z. So then z tangent of 28 degrees equals 82, which then means that z is equal to 82 divided by the tangent of 28 degrees. So then we should now get a 2 decimal place approximation. 82 divided by the tangent of 28 degrees would give you about 154.22. So the approximation for this is 154.22 for Z. 2 more exercises, then we're done. Oh yeah. Well, let's see here. We can definitely establish that this is a right angle. This has an angle of 45 degrees. This has an angle of 30. Let's see what we're going to do. This has a length of 160. Up here is W, up here is Z. All right, well, let's really stop and take a look at this here. You have one triangle, one right triangle that really is split into two. You have a smaller 45, 45, 90 triangle. And then if you consider the whole thing, you have a 30, 60, 90 triangle. So, let's go ahead here, start with our 45, 45, 90 triangle, find W. We know that in a 45, 45, 90 triangle, both legs have the same length. So by default, that would mean W is also 160. So that's easy enough. W is also 160. Well, now we need to find the length of Z. So here's where it's going to get fun. The whole thing is a 30, 60, 90 triangle if you take out this middle line here, right? The shorter leg is equal to 160. So the shorter leg is 160. That means this whole angle here would be 60. So W plus Z is the longer leg. That's going to be equal to the length of the shorter leg times the square root of 3. Well, at this point then, we can just substitute these in to solve for Z. Z plus the value of W, which is 160, is equal to 160 times the square root of 3, which means Z equals 160 times the square root of 3 minus 160. And you could get a decimal approximation if you wanted to, or in this case, you could just leave your answer like that. So W comes out to be 160. Z has a length of 160 times the square root of square root of 3 minus 160. I got one more exercise, then we're done. So that one did not involve any real trig in it. Now this is another interesting one here. Actually, why don't I make this one a little bit bigger, because this is a funky one. There we go. That's more like it, ain't it? All right. Alright, what do we got here? So this is a right triangle. This is 60 degrees. This here is 42 degrees. This here is 900. This has a length of Z. This has a length of W. Okay. So, we have one triangle split into two. Really, it's two right triangles. Well, it's one right triangle inside of a big right triangle. The smaller right triangle is a 30, 60, 90. That means the missing angle here is 30. So the length of your short leg W, since it's opposite the 30-degree angle, would be equal to the length of your longer leg, 900, divided by the square root of 3. Which then, we can of course rationalize the denominator, which would then give us 900 times the square root of 3 over 3, which would then give us, of course, 300 times the square root of 3. But let's get a decimal approximation for W, right? Let's do that. So 300 times the square root of 3 is approximately 519.62. $519.62 for W, once you do all the square roots. Okay. So we found W. Let's actually go ahead and put that in right here. This is going to come in handy because next we need to consider the whole right triangle. In order to have a chance of solving for Z, we have to consider that this angle's 42 degrees, that this 60's gone away. This is one big right triangle now. So, of course, set up your tangent of 42 degrees. The tangent of 42 degrees equals your opposite leg of 900 over your adjacent leg. Since we're considering the whole triangle, it's actually going to be Z plus 519.62. Since you're actually considering the length of the whole leg, it's going to be Z plus 519.62. And now you multiply both sides by the denominator, you would end up getting Z plus 519.62 is equal times the tangent of 42 is equal to 900. Well, here's where it gets tricky. Let's start with dividing both sides by the tangent of 42. You get Z plus 519.62. That'd be equal to 900 divided by the tangent of 42. You know what? I think we got W well enough now. Let's erase that. Everybody got W. I'll just leave that up there. And then that means Z is going to equal 900 over the tangent of 42 degrees minus 519.62. So that's looking a little bit hideous, isn't it? We do the math, we should get a decimal approximation to two decimal places. So let's go ahead and do just that real quick. The few steps in your calculator, so 900 divided by the tangent of 42, so that's about 999.55. So take that minus 519.62. So you get approximately 479.93. So that would be the value for Z. So what I did first, of course, I consider these as two separate triangles we wanted to solve for W, only look at this right side as a 30, 60, 90 triangle. Then I took the decimal approximation. Once I did the radicals, I got W being 519.62. Then in order to solve for Z, I actually have to consider the entire right triangle, meaning this angle's 42. So I set up my tangent ratio, but the tangent of 42 in this case is equal to the opposite side of 900 divided by the length of this whole side. Since we're considering the triangle as a whole, it would be 900 divided by Z plus 519.62. And then I did some multiplication and division. I ended up getting to this for Z, and Z ultimately is 479.93. So that's it for the tangent ratio. The next lesson we will talk about the sine and cosine ratios. So I hope everybody has a great day. Take care.